Okay, let's unpack this. We're diving into something that might sound, well, deceptively simple, maybe even sweet. The math behind how sugar crystallizes.
And what's truly fascinating here, I think, is how this specific, um, seemingly small piece of physics and math, it connects directly to a much larger, absolutely crucial field,
Hmm.
global food security.
Food security, really, from studying sugar crystals. Okay, that's
Yeah.
that's where it gets really interesting, and a bit surprising, honestly. Our source material digs into a very specific link here. It talks about using the mathematics of sugar crystallization,
Yeah.
and specifically the concept of differentiation to model the rate sugar forms crystals.
Exactly. Because when you think about food security, you're often thinking big picture production, distribution, access. But the stability and quality of food after it's produced is also, well, vital. For lots of food products, controlling sugar crystallization is just critical. For texture, shelf life, right? Preventing spoilage.
Right.
And differentiation is the mathematical tool used because fundamentally it's all about understanding rates of change, how fast things happen.
Okay, so differentiation helps model rates of change. We get that. But how does that apply specifically to sugar crystals? In a way that actually matters for food. Is it about how fast they grow or, like, how many form?
It's really both, actually. Differentiation lets us model different aspects, things like the rate at which new crystals nucleate, and that's like start forming, or the rate existing crystals grow larger. And we can model this based on factors like temperature, concentration, maybe even other ingredients in the mix.
Oh, okay.
So by using differentiation to analyze these rates, manufacturers, food scientists, they can predict pretty precisely how a product will behave over time.
So it's not just a simple will it crystallize question, but more how fast and under what conditions.
Yeah.
And that how fast part, the rate modeled by differentiation, that gives you practical control.
Precisely. Yeah, knowing the rate lets them optimize processes. Think cooling times for candy or storage temperatures for jams and preserves,
Sure.
or even predicting when something like honey might start to crystallize into that, less desirable texture.
Mhm.
And this control directly impacts shelf life, obviously. It reduces waste from products going bad or just becoming unpalatable, and it helps ensure consistent quality. These are all components of a stable food supply chain, really.
Right.
It helps prevent those problems like crystallization causing jams to seize up or ice cream getting gritty, issues that can lead to pretty significant product loss.
Wow. Okay, so that tool, differentiation, the one you might remember from calculus class for finding slopes or understanding velocity. It's quietly being used behind the scenes to make sure your jam isn't full of crunchy bits and lasts longer. And that somehow scales up to impact food availability. That really shows how these fundamental math concepts aren't just, abstract textbook exercises.
Not at all. They are silently at work enabling these crucial real-world processes. This dive, though it's brief, it really shows how deeply interconnected math, chemistry, and even things like global logistics are.
Absolutely. Yeah, we took a quick but I think pretty surprising deep dive today, looking at this unexpected connection, the role of differentiation in modeling sugar crystallization rates, and its surprising relevance to the much bigger picture of food security.
Right. And maybe this leaves us, and you listening, with a thought to ponder.
Hmm.
Consider how many other fundamental mathematical tools, maybe ones you learned years ago and haven't thought much about since,
Yeah.
how they might be silently working away in crucial everyday areas of the world around you, in transportation systems, energy grids, public health modeling, and yes, even in ensuring the food on your table is safe and stable. It just reveals these surprising layers of complexity and interconnectedness just waiting to be seen.